Okay. Hi everyone, Maxime here, hosting your regular bite size. Today, Fran, working at National Genomics Infrastructure, will present seqinspector. As usual, you'll be able to unmute yourself at the end of the talk to ask your question, but you can also ask them on Slack later on. Now, to you, Fran.
Thank you. So yeah, I'm talking today about NF Core seqinspector as a presenter this time, not as the host. How the tables have turned, right? So yeah, what is seqinspector used for? So it is intended to be a hopefully fast initial QC tool for any kind of sequencing data, which would give you a general overview of, for example, things like a quality of the individual samples, the yields. It should confirm the species that you're working with, but it could also be stuff like coverage. So anything you can think of that is actually not doing real analysis of the data, but it is only a QC. The people or places that would be using the tool like that are people like us at a sequencing facility. So I work at NGI. But it could also be large groups that have their own sequencers and that do regularly sequencing of different groups, maybe even on the same sequencer, and they want to make sure that their data is okay before proceeding with any further analysis. That being said, there could also be a third group that would be beneficial or benefiting from a tool like that, and that would be anyone who wants to very quickly check, is this data really the one that I wanted to? Let's say you download something from an open repository and you want to make sure that this is really the data they talked about, then you can run seqinspector and just quickly compare the QC metrics. So also seqinspector is at least intended to be run with all kinds of sequencing data. At the moment, we are targeting it mainly for Illumina data. It would also work with Aviti, for example, but long read is not part of it yet. So I want to also mention what seqinspector is not. It is not meant to be a data analysis tool, not even in the first steps. So this is really only targeted for QC. And we only will accept QC tools to be integrated in this pipeline. This might be tools that you then use in other pipelines for an actual analysis or start of analysis, but within seqinspector, it will only be used as a QC tool. The output is not a data set, so it's not something that will then be used further in analysis, but the output is meant to be a multi-QC report, or in some cases where it's not yet integrated into multi-QC, you can still use or see the entire output of the specific tool in its own results folder. But the output is not a data set. And also it is possible that seqinspector is downsampling your input, and that is mainly for speed. So if you think like, oh yeah, I mapped this now to the target genome, I can just use this output to continue with it. That is actually in a lot of cases not true. It might just have mapped, I don't know, 100,000 reads of your data set. So always be careful with that. Don't use seqinspector outputs downstream. Always stop there. And if you have to run the same tool again on the full data set, do that separately. Now let's have a look at the pipeline itself. This is an overview. It is at the moment a fairly simple one. We have some inputs, then we run through a set of QCs, and afterwards we filter that all into multi-QC, and we'll get a bunch of different reports at the end. I'm going to go through this one by one, so you don't have to remember this all. But the principle of the pipeline is very simple. So let's have a look at the sample sheet, which will also define our inputs. First, we have the sample. This is just a custom sample name, as with most NF Core pipelines. It can be identical in several times. For example, if you had your sample on more than one lane on a sequencer, you will have several entries for this. And so this doesn't have to be unique. Then the second step is, or the second entry is your first FASTQ file. Always have them as a zipped file, so FASTQ-GZ or FQ-GZ. And then once you have the first one, you can also have paired end reads. The same applies, either a zipped, so FASTQ zipped or FQ zip. The second one is optional, so you can also run it if it's not paired end. And now we're getting into the more interesting parts of the sample sheet, which is the run dir. This is, I assume, nearly unique to seqinspector. And it's basically the run folder that comes out of, in this case, an Illumina sequencer. So at the moment, this only works for Illumina. And if you do not provide a run dir, then the whole module will be skipped and it will just not be part of it. What happens is basically it will retrieve some information of the run and it will dump it into the final multi-QC report. So you will know which software was used on this specific sequencer and which real-time analysis version was used. This is often not so important for individual groups because this will not change, but for sequencing facilities like myself, this might be interesting metadata to convey to your users. So the final part of the sample sheet is a bit of the heart and soul of this whole pipeline, which is a list of tags. And with these tags, one is able to group samples into individual reports. So let's have a look at this one as well. Here we have our tags. And basically the first report that you're going to get is a global report, which includes all the samples. But then it is going to use these tags to group them based on the tag. So for example, we will have one report that contains all the samples that have the tag paired sample, and one report that has a tag lane 1, and one report that has all the samples with lane 2 tag, and so on. And like that, you can basically have a lot of different projects on one flow cell, and it will create a report for each individual project without you actually intervening in the end and starting to make reports for all of those. So it will sort it out for you. Also, in this case, they are one after the other, but hypothetically, you could have the paired sample tag also in the last sample, and it would still group it. So the order here is not important. You could also have the paired sample at the end, for example. So again, the order is unimportant. It's just important that you have the tag there. So the QC tools, since I'm in Sweden, I think of this as the smörgåsbord for QC, meaning you can basically pick and choose which QC tool you want to run. And some of them might be very similar, but some people prefer the flavor of this tool more than the other tool, so they will choose it one over the other. But the idea is to have, like, in the end at least, a very big amount of different QC tools, and then you just pick which ones you would like to run, and maybe that is the standard then in your group or at your facility. And at the moment, the board is not that much filled, so we have pretty much 4-5 tools that we are running or that you can run and choose from. And if you do not want to run a specific tool, you just exclude that tool with the skip tools function. Then the tools that we have is first seqdk, which is a subsampling tool. This is global and for all samples. So for example, if you have, I don't know, millions of reads, but you want to be very, very quick, you can subsample it all to 100,000 or something, and then it will run a lot quicker. Just be aware that would also then impair the results from the FastQC, for example, that gives you a yield. Then we have a tool that runs in the end basically Picard, which will give you some alignment statistics to the genome of interest. And obviously, if you want to align it to a genome of interest, you will also have to provide a FASTA file of your genome. And that will then create the indices with BWA-MEM2 and then give it into Picard. The second tool is seqfusdots. It's a fairly simple one, giving you a read length overview. This will also be part of the multi-QC report. And then the two workhorses of QC, at least at our facility at the moment, We have FastQC, which is giving you all the base statistics, meaning the quality of over the reads or over different samples, the yield of the samples, duplication levels, and a few other things. And finally, FastQScreen. We use this. So basically with FastQScreen, you will map a subsample of reads, I think in this case 100,000, to species that you decide on your own. And we use this as a form of contamination control or confirmation of the species that we expect in a sample. At the moment, FastQScreen is using by default 3 references, which is E. coli, Vix, and yeast. And probably this is not relevant to most people. So you will not want to map to either of those. The only reason they were chosen is because they are very small. So we can actually package them with the pipeline. If you actually want this to be useful, the idea is that everyone makes their own reference config file. So basically, you would add your species of interest to a config file that looks the same as the one that I've shown here with the default references. And then you also have to give a bow tie to or different aligner index. And you would then add this reference config file to the command line with the FastQScreen references command line tag. And that should then also map it to your species that you're actually interested in. And we kind of did this on purpose because every group and every core facility will be interested in a different set of those. Because they may have a specific likelihood or higher likelihood of a specific contaminant. So what is happening next with seqinspector? This is not to understand as a roadmap and more as a personal wish list. So it might not all happen and it might not all happen for the next version. But we are going to be at the NFCO hackathon in Uppsala. That is happening already next week. And we actually have a local site, so it is restricted to in-person on-site people. And my wish is that there we will at least start to work on the migration to strict syntax, which is important because the deadline is approaching. Also, I would like to improve the multi-QC report for better readability. And there's a couple of modules that have been excluded from the first release for just easiness reasons. For example, Kraken 2, I'm pretty sure is as good as ready to be included. Also, CheckQC, I've seen there is a PR for it, and a few more. Also, there have been, I think now 2 hackathons ago, there was an effort to make this pipeline also work on BAM files so that we can have long read support. Originally, I was not too much a fan of it, but then I heard that actually PacBio is using only BAM as output files. And I think by now, ONT is moving in the same direction. So if we want to have long read support, we probably have to have an input for BAM files as well. And also very much discussed from the beginning and still under discussion is a better tool to select, a better way of selecting the tools. Because at the moment, you would have to skip every individual tool that you don't want to run. And while it is currently only 4 really that you have to skip, once we actually have our table full, let's say, it would become a very, very long list. And we would like this to be better. So with this, I already want to say thank you to everyone who contributed to this pipeline. All the people from Uppsala, from Stockholm, and from all over the world. So I would definitely have not been able to do this on my own. And if there are any questions, please do not hesitate to contact us in Slack. You might need to wait a day or so for an answer. We're not quite as quick as other people, but we are definitely willing to. So don't lose hope on us. So with that, thank you very much. And I think I was quite quick. So yep. And now I stop sharing.
No, but thank you very much, Fran. That was very interesting. I'm looking forward to see like all of the new features coming from the hackathon. I might join you with the hackathon.
No, you have your own group.
Yeah, but I might just join you to enjoy the fun.
Okay.
That's all.
You're very welcome.
Thank you. James, Ram, any question?
I have two.
Oh, go.
Although honestly, they've probably both properly been answered in the last slide of where to go next. So when you first talked about the species confirmation with the alignment with FastQ screen, I was wondering, okay, but what about metagenomes? Is that related to the Kraken 2 thing at the end, or is that just a replacement?
I mean, in the end, the idea is to have as many QC tools as possible, and you just run the one that works best for you. I'm not familiar enough with the metagenome field to know what the best tool is for that. Maybe you know, actually.
I have ideas for sure, yes. But we could talk about that another time.
But the idea is not to be exclusive and say, oh, we only want to have one tool that can do this thing.
Yeah.
We are very happy actually to have all the tools in there, even if they have the same functions.
Yeah.
And then have the people to decide which ones they want to run.
Yeah, it was more, did you have metagenomic sequencing on your roadmap? Because I do know that, like, for example, SciLife does do a lot of metagenomic sequencing. But
not specifically. Not specifically.
Yeah, okay. Fair enough. Yeah. And then my other question was what about long read stuff, but you talked about that already. So yes. That's everything from me. Very good talk. Thank you, Fran.
Thank you.
Yep. I think James asked my question. so good.
Thank you.
Yeah, thank you. Hopefully I'll try to join you guys at the hackathon.
Awesome.
Looking forward.
But if you have any specific tool that you would like to be included, you can just drop by our Slack and ask for it. Mm-hmm. We definitely add it to the list.
Yep.
Okay, I think with that I can close the recording. So thank you all again, and see you soon.
Bye-bye.
Bye-bye.